is André Almeida, and I'm based in Brazil, and I'm a kernel engineer at Collabora, an open source consultancy. So today I want to share some tips and tricks from my kernel development workflow that I have in Arch Linux. And this is an overview of the things I'm going to show here. It's kind of a tutorial. And first of all, I use Arch Linux for both professional and personal use. For professional use, I found very handy to have a lot of very up-to-date packages, and as part of Arch philosophy, they are very close to mainline, so maintainers rarely apply patches to each. And for instance, if I want to boot a custom kernel, I don't need to change anything in the user space. Everything will be ready to run my custom kernel from mainline. And also, in this tutorial, I've been showing how to use a virtual machine, because booting your own custom kernel requires some time, and it's very painful to reboot your machine just to check if your print is working. And so also I found very useful to have a different root FS, so I can do some experimental changes on all the stack, and I do not risk breaking my system. But if you want to use the same root FS of your installation on your testing, I recommend you checking the tool called VirtMe, that is a wrapper around QEMU. And one more thing that I found very useful from Arch Linux is the keep it simple philosophy. And on my workflow, I try to apply this principle as well. So for my workflow, I just need 2 additional tools. That is the Arch install scripts, that will provide the same scripts that you use on installation disk to install a new Arch Linux, and QEMU, that will provide the virtualization. And first of all, we need somewhere to store our rootfs, and for this I create a file of 5 gigas. I use Concrete because in that way I can have a spare file that will grow as need. It won't be using 5 gigas from storage. After that, I format this file to have the ext4 file system, and then I just mount this file in a directory. After that, we can use the backstrap, that is the same software, the same script that we use in an Arch Linux installation, to create the all directories and install some basic software there. If your system is up to date, you can use the flag -c. So instead of downloading the package all again, you just use the cache from the whole system. And after that, your rootfs is complete in less than 2 minutes. Also, this is useful. It may be useful as well to install an editor like Vim and the DACP client as well. And using backstrap and the cache flag, you won't need to download anything from the internet. So it's a very easy and fast setup. And since the rootfs is mounted, we can easily copy our SSH key there. And also we can use chroot to change the root password. And if you are always going to log in as root, you can use you can change the systemd configuration, so you can always auto log in the root user. Those steps will help us in the future to make the use of the virtual machine easier. And now, for using QEMU, these are the flags that I use. The first flag is HDA, that is to tell QEMU where is my disk. And then I use the kernel flag to specify the path of my compiled kernel. In this talk, I'm not covering how to compile your own custom kernel, but if you want, you can also use this flag with your current installed kernel of your system, that is probably located on somewhere in boot, the boot directory. And also I use the append flag to use some kernel parameters. For instance, the root parameter tells to the kernel where it can find the root, in which disk is the rootfs. So here is the first disk, the SDA. We send also the parameter read write because we want to change the rootfs. And with console TTISO, you can tell to the kernel where it should display the output and the shell when it boots. Some useful flags as well is the flag M, so you can specify how much memory do you want to give to your guest. Enable KVM will make a huge difference on your performance, and remember to enable virtualization on your BIOS menu on your motherboard. And also I like to use with the flag no graphic, so QEMU will just run as a console application like Vim. And also use the SMP, you can specify how many cores do you want to give to your guest. If you want to use networking inside your machine, for instance, if you want to use git clone or use pacman to get a new software, you can easily enable it by just starting the DHCP client that you installed earlier. Here I'm using the ACP CD for that. So copying and pasting files isn't a very efficient way to share some files with the guest. So what I do is I create a shared folder. In order to do that, you need to be sure that your kernel has some modules enabled, like mainly modules that are related to the 9MP sharing protocol. And after that, in the QEMU flags, I will add two devices, a file system device and then a virtuio 9P device. So you use this flag to choose which directory you want to share. In this example, I'm sharing a directory named files inside my home directory of the user, and the name of the virtual device will be shared folder. And then inside the guest fs tab file, you just need to add this line for the shared folder device and specifying where do you want the multi-point to be inside your guest. During your testing, you may be required to use some graphical applications, and I know two ways of doing that. My favorite one is the first I'm going to show, that is the SSH Forwarding, but you can also use the QEMU Display. So in order to use the SSH Forwarding, first you need to install the OpenSSD server on your guest and initiate the daemon. You can find it on the OpenSSH package. And then you change some configuration on the SSH configuration file. Namely, you permit the root logging and also you say yes for X11 forwarding. For the QEMU flags, you need a basic to create a basic network card. And here we forward the port. You need to forward some port so you don't mess with the host ports. Here I am forwarding the port 1337 to the port 22. So basically is that this is the setup. And then if you run ssh-x root at localhost, and then you specify your port, and just by doing that on your guest machine, you will be able to run graphical applications. Here's an example. On the left side, I have my host, the guest machine, and then on the right side, I will use SSH, and then after doing that, I can open the Xlock graphical application. And now, if you want a more complete graphical solution, you can run a whole compositor inside your virtual machine. For that, the first thing you do is to remove the no graphic option on QEMU flags. And then after that, you need to install some kind of compositor. Here I'm using Wayland because it's very lightweight. So I install the package of Wayland and Wayland. And then after that, you need to configure your Wayland to run on Wayland. And so you need to create this file on your home folder and say Wayland equals true. Then you just run Wayland on the command line and the Wayland environment will appear. You can use your mouse to open the terminal, and inside there you can call the graphic application that you want. When you are done, you just hold Ctrl, Alt and Backspace, and Wayland will close. And this is a very basic setup using QEMU Display. Here you won't have support for clipboard, for sharing the same clipboard, or multi-monitor support. If you want to do that, I recommend you to use the Virt Manager, that is a front end for QEMU with libvirt, and then you can have a very nice graphical experience. Okay, and that's it. This is how I spawn new virtual machines if I need to do some testing, and also sharing files with my virtual machine, run graphical applications, and as you can see, it requires almost no new program. Everything is command line applications, so it's very easy to create some bash scripts. Here is the link for a Git repository where I store my scripts, and also here's a link of our blog post at the Collabora website where you can find more detailed explanation of my talk. And thanks for watching, and now I would like to hear if you also have some tips of kernel development workflow. Thank you.